All right, here we go. So guys, we are interpreting graphs. So we are going to show on these graphs what it would look like, all right, as an example here on the graph part itself, and then we're going to make a drawing that goes with it. So over here by positive direction, I would like everyone to write the word east. By the negative direction, I would like everyone to please write the word west. West, whatever. All right, so east is our positive direction. West will be our negative direction. So we could be like, okay, this is to the east, this is to the west. This is like positive, this is negative. All right, however you need to help this kind of click. So we said before that when you are not moving, all right, you are a flat horizontal line. Flat line in a show means like the person's dead. When the person's dead, we say RIP, right? RIP, resting in position. They're not changing their position at all. So this blue line would represent a horizontal line. The person's not moving. But now this is saying the person is stopped in the positive direction. So how would I then show that? Anyone know? Have an idea? Good. You're going to put a horizontal line, all right, above that axis. It could be here. It could be there. It could be either one of these, all right? So any one of those works. So you would draw in a line, well, bam, like that. That's telling me that this person has stopped. So you would draw that line in, and now we're going to just draw a little picture. So if this is our starting axis, right, this is the x-axis, little dot, home base, and we have west over here, we have east over here. This person needs to be just kind of standing still to the right of that little dot. That dot represents our x-axis there. So you're just going to show a person kind of just chilling. So we're doing little stick figures today. All right, they got their hands on their hips, like, oh, this is ridiculous. They're just chilling. They're standing there. Okay. Sandra, what would it look like? How would I draw a line showing that a person is stopped, but in the negative direction? The line pointing to the left?
Yeah.
So if I started like over here, and now that I'm like dragging it over this way, is that what you're saying?
Yeah. That's negative.
Well, look how we wrote this, right? We said up here that positive direction is east, negative direction is west. So if we said that west is down here because that's in the negative direction, and east is up top, that's in the positive direction. So then where would I want my line to be? Underneath, good, underneath the x-axis. Now, is this okay because it's a straight line? No. All right, it's not a flat horizontal line. That's not resting in position. So this blue line here would represent this dude resting in place, not moving. So to draw that, little start button here, that's the x-axis. We draw a little east over here, draw a little west over here. Now we got to just draw this person standing still that's in the negative direction or to the west. So same thing. Here we go, guys. Stick figures. You're going to start off with a little triangle like this. Boom. Draw a little straight line up. Person gets ahead. And then, these are the arms. They're like, gosh, this is so annoying. They got the hands on the hips, like just waiting. Okay. So those would be showing that an object or a person is stopped, all right, above where the origin is, all right, in the positive direction. This is what it would look like if the person or object stopped below the origin or their original starting spot. Okay. Next. Constant velocity. What about constant velocity? Well, we talked constant velocity as a nice straight line that is in a slope. Okay, the slope can be either positive or negative. And then we also talked about the steepness of the slope. So let me ask this. Constant velocity would have to be a straight line, all right, not straight up, not horizontal, but it's got to be something like one of these. If this was line 1, this was line 2, and this was line 3. 1, 2, or 3. Which one of them is moving faster? 3. Why? So the steeper it is, the faster the constant speed is going to be. All right. So you could write either one of these as a viable answer. You could draw either one of them as a viable option for your constant velocity. But I'm going to go like this. So either way you wanted to do it, I would say, yeah, okay, here's my constant velocity. Now, since we're going in the positive direction, it's got to be above the x-axis. So here would be, let's say, my starting point if this direction is to the east. All right, guys, I'm going to show you how to draw a person running, as we should all be writing this down.
You came out yesterday.
I have no idea what to do.
All right. Well, it's good. It's very good. So what we're going to do is you're going to start with a greater than symbol. Just like that. It's almost like an upside down 4 kind of a deal. To right about here now, at the top of that, you're going to draw the head for the person. Down here is going to be their like kind of their shin. And then from right here by the head, you're going to just kind of draw a little bit of a line down. It can be at a very small slope. And then run.
Doing this for 40 minutes. Come on, guys.
And then we are going to kind of just draw this. All right, so this is, boom, person running.
Come on. Take some responsibility upon yourself. I'm not here to babysit you.
Okay, we're going to draw 3 little lines behind it like this. Now, I want those lines equal length for a specific reason. And that reason is show a constant speed. Okay, now what about a constant velocity underneath? Just like we showed before, it could be either one of, it could be something like this, that's kind of showing a constant velocity pretty quick because it's a very steep slope. This can be a constant velocity. This can be a constant velocity. This can be a constant velocity. But the steeper the slope, the faster that speed will be. Now, this velocity is going to be right in the negative direction. So we would say, right, this is like our west, east, right, your starting spot. So when we draw in this, we'll put the starting little dot over here to the west. And now the person is going to be turned around. So instead of a greater than symbol, we're going to do a less than symbol. Slope down to kind of make it look like a 4, sort of. Person's head. The shin. A line down. All right, the top of his arm, and then the forearm coming up. Then the other arm is kind of back, and you have the forearm kind of going down a little bit. Now this is showing running to the west. Now again, since we're looking at constant velocity, the little airlines behind him should be constant. It should be the same length, same size. Okay. Now, we got to show speeding up. Dang, I'm not 100% sure what speeding up was. Well, this is where we can go back to the side that we were looking at yesterday, and we went over again this morning, right, earlier on. That when you are speeding up, or when you're changing your speed at all on a position time graph, there's going to be a curve. Now, if that curve gets steeper, that means it is speeding up. So right here, it's getting steeper, so it's speeding up. Look at this one up top. It starts off kind of flatter, and then it starts to get steeper. So this thing is speeding up, but now it's going in the opposite direction. And what happens when it starts kind of steep and then flattens out? It's changing its speed. It was going kind of fast, and now it's coming down until it gets to that little flat line where it stopped. So this is a speeding up. This is a speeding up in the opposite direction. This dude is a slowing down. So on this, we would then show our speeding up. A curved line that gets steeper as we go. Can make it fit. Mine just didn't quite fit like that. All right, it gets steeper as we go. So to draw this, oh dang, start right. We're going to the east, positive direction here. Draw the same thing, right? This looks like a 4. Head, leg backwards, arm, arm. Now these airlines, I want to show them getting bigger like that. And that should hopefully tell us that this thing is increasing. All right, it's increasing. It started off like here, it's increasing, it's increasing. Going to the negative direction, or going to the west, speeding up in that direction, that would look like this. Starts kind of flat, and then it gets steeper, right? Going in the opposite direction. So that would be speeding up in the opposite direction. And the same thing for our drawing. Just like that origin line. Okay, this is to the west. Less than symbol. Head. Leg. One of the arms. The other arm. All right, and our little airlines, they should get bigger as it goes. Now it's accelerating to the west, the opposite direction. All right, it's not like telling you that it's moving backwards. He's not, the person themselves is not literally walking backwards. They've turned around, they've changed direction. Okay, so then our slowing down. What would the slowing down look like? So guys, if it's changing speed, it is at a, there has to be some kind of what to it? What do we call that? Curve. All right, we need to have a curve line. So the curve line for speeding up was it kind of started a little bit flatter and got steeper. So slowing down would be the reverse. It would be showing it started steeper and then kind of flattened it out a little bit. So if we're moving to the east, all right, we're going in the positive direction, it should look like something like this, right? It started off kind of steeper and then starts to flatten out. Quick draw. I'm going to show this. All right, so everyone's going to do kind of like a longer, greater than symbol like that. I'm going to put a head up here. You're going to draw a second little line right there. And then two little lines up like this to represent the person's feet. Just a little line down, a little line down. And then we're going to shorten the little air. All right, the first one's somewhat longer. And then they get a little bit smaller, showing that he's slowing down, right? He's like hitting the brakes literally, and then you can even do something silly like this, put some little dust cloud. Look at that. That's beautiful. This is physics and art. Oh yeah. So then what would it look like if the person or object was slowing down, but in the negative direction? Remember, if the curve gets steeper, it's a speeding up. If it flattens out, it's a slowing down. So it has to start a little bit steeper and then kind of flatten itself out. And then the drawing is very similar to the guy over here. We're just going to kind of flip it. Little feet, head, arms. Whoa! 3 lines that get a little shorter. Just a little dust cloud. Hitting the brakes. Bam. So now you guys learned how to draw a person running at a constant speed. I mean, you show how to draw these things out on a graph, but also how to draw a stick figure version of them as well. Cool? Cool. So again, if we did not know what, all right, these things look like, it should be like this. All right, positive direction. Yes, yes. So it started off like that, got steeper over here, started kind of flat, got steeper. Constant velocity in the positive direction could be like this, this, this. Negative direction could be like this, this, this. Bop. Stopped in the positive direction means you got to be above our little origin. Doesn't matter exactly where, but you're stopped in the negative direction or to the west. All right. it would look like that. And then if we forgot what all the little pieces meant, okay, our horizontal line means the object's not moving. When the curved line is getting steeper, it's accelerating or speeding up. A positive slope, that's a straight line, means the object is moving at a constant velocity. All right, again, here, the curve is getting steeper. Starts kind of flat and it gets steeper, so this thing is speeding up, but it's just now going in the opposite direction. Then they're going to slow down. So when a curved line flattens out, the object is decelerating or slowing down. A straight line, but now it's kind of a downward slope. That means the object is moving still at a constant velocity, but just in the different direction. Okay, so those are kind of what all the lines would look like, and that's what they mean on a PT graph, a position time graph, or a distance time graph. All right.